So we're going to take a look at the values of sine, cosine, and tangent in quadrant 1, quadrant 2, quadrant 3, quadrant 4. On the first graph, I have labeled quadrant 1, quadrant 2, quadrant 3, and quadrant 4 and highlighted them in case you need a reminder where they are. So allow me to zoom in and consider an angle in quadrant number 1. Quadrant number 1, I have my initial arm along the positive x-axis. Now I'm going to have some terminal arm somewhere in quadrant 1. And I'm going to say, let's suppose that we go through some arbitrary point x, y. What I can do then is I can make a right angle triangle right there. Hey, there's my triangle, my right angle triangle. Now, is it any coincidence that I rewrote sine theta, cosine theta, and tangent theta with respect to x, y, and the radius vector r? Probably not. If I take a look at this triangle that I just drew, the length of the base will be x, the height will be y. Still holds true. But what is going to be really important is considering this point x, y in quadrant number 1. Now in quadrant number 1, we know that x's are greater than 0, y will be greater than 0, and the radius vector r is greater than 0. So that sine theta will be given by my y divided by my radius vector r, by definition. But if we already know that y is positive and the radius vector is positive, we can conclude that sine theta is positive for all angles in quadrant number 1. Probably some of you at home are saying, well, aren't all angles in quadrant number 1 acute? Definitely. Not ugly. They're very acute. Moving on to cosine theta. Now, cosine theta, by definition, is the x-coordinate divided by my radius vector r. Now, just plugging in, if we take a look at this point right here, x is always positive in all angles in quadrant number 1. So what does that mean? Well, it really means that x will be positive, my radius vector r is positive, so a positive divided by a positive will also be a positive. My tangent theta. Now tangent theta by definition is y over x. And in quadrant 1, what do we notice about x and y? Well, x and y are both positive. So tangent theta is a positive divided by a positive, and this will yield a positive number. So what do we know about quadrant number 1s? Quadrant number 1s, sine, cosine, and tangent are all positive for all angles in quadrant number 1. Let's move on to quadrant number 2. What do we know about angles in quadrant number 2? I'm just going to draw an angle in quadrant number 2. There we are. My angle would be defined like this. So there's theta. I have a point here, x, y. And I'm going to make my right triangle right here. So what do we know about angles in quadrant number 2? Well, the x-coordinates of all points in quadrant number 2, the x-coordinate has to be negative. The y-coordinate is positive, and by definition, my radius vector is also positive. So what do we know? Sine theta. Well, sine theta is going to be equal to my y divided by my radius vector r. Well, we know that sine theta is going to be my y divided by my r, yet all the coordinates for the y-coordinate will be positive in quadrant number 2. My radius vector r will also be positive. So what can we conclude? Well, we can conclude that sine theta is a positive divided by a positive, or sine theta is positive. Cosine theta, for all angles in quadrant number 2. Well, cosine theta is x over y. Remember? Sorry, incorrect. Is x divided by my radius vector r. My mistake. And this will yield that my cosine theta of any angle in quadrant number 2, which ranges from 90 to 180, people call these obtuse angles. Well, my x-coordinate in quadrant number 2 is always going to be negative, and my radius vector r is positive. So a negative divided by a positive is going to be a negative. So we can conclude that all angles in quadrant number 2 have a negative cosine value. So cosine is negative. Now tangent. Now I don't know if I've mentioned this. If you take a look at tangent, tangent is just really the slope of the terminal arm. Well, since you have the origin and you have the point xy, the rise will be given by the coordinate y, and the run is given by the coordinate x. And that's true for all coordinates. For all quadrants. So now I have tangent theta is equal to my y over my x. Now I'm going to speed things up. In quadrant number 2, my y's are positive, and my x's are negative. So a positive divided by a negative is a negative. So in quadrant number 2, I have sine theta is positive. Cosine theta is equal to negative. Tangent is negative. So for example, the tangent, I'm going to make this up now, the tangent of 131 degrees, well, I actually don't know what that is. But I do know 131 degrees is in quadrant number 2. So all angles in quadrant number 2 have a negative cosine value. So therefore, all I know is that the tangent of 131 is negative. Try it out. All right, picking up the pace here. Quadrant number 3. What do we know about quadrant number 3? Well, I'm just going to draw my terminal arm, my initial arm, my terminal arm. This is my angle in standard position. That's what it looks like in quadrant number 3, down here. Well, what do we know about angles in quadrant number, what do we know about point xy? We still have point xy on our terminal arm. We know that x's are negative and the y's are negative. So the sine theta is equal to my y coordinate divided by my radius vector r. So sine theta is going to be a negative divided by a positive. Y is negative, radius vector r is positive. So we can conclude that sine theta is negative. Now for cosine theta is equal to x divided by my radius vector r. Well, x's are negative, so cosine theta is going to be a negative. My x-coordinate is negative divided by my radius vector r. It's always positive. So I can conclude that cosine theta is negative in quadrant number 2. And now my tangent theta. My tangent theta is y divided by my x. And when I take a look at this tangent theta, my y-coordinate is negative, my x-coordinate is negative. A negative divided by a negative is actually positive. And that's true for all angles in quadrant number 2. Now, tangent, some people have a difficult time, but I actually find it's almost the easiest. This is my terminal arm. Now, I just said, maybe you want to write this down, tangent is slope. This terminal arm, does it have a positive or negative slope? Well, it has a positive slope. So therefore, the tangent is positive. Last but not least, motoring through here. Sine theta is my y-coordinate divided by my radius vector r. So there is the angle in quadrant number 4, and we'll call this theta. So I know that my x's are positive in quadrant number 4 and my y's are negative. So sine theta is my y coordinate divided by my radius vector r. So sine theta, well, since my y's are negative and my radius vector r is always positive, I can conclude that all angles in quadrant number 4 have a negative sign. Cosine theta is equal to x divided by my radius vector r. All points in quadrant number 4, the x values are going to be positive. By definition, my radius vector r is positive, so all angles in quadrant number 4 will have a positive cosine. Try it out. Identify an angle in quadrant number 4 like 330. The cosine of 330 degrees will be positive. No need to take out your calculator, or take it out, give it a spin. Now, tangent theta is going to be my y coordinate divided by my x. Now, tangent theta, my y coordinate is negative. My x coordinate is positive. Therefore, a negative divided by a positive is a negative. So I have my ratios here, where they're positive or negative. All right. If you go online, you might know the cast rule. I find the cast rule a little bit deceiving. There's an easier way to pick out where sine, cosine, and tangent are positive and negative. Sine is always going to be positive in the quadrants where y is positive. Sine will be negative wherever y is negative. Cosine is positive wherever the x coordinates are positive, namely 1 and 4. Cosine is negative in those quadrants where x's are negative. Tangent. Well, tangent's a little bit different. All I simply do is I look whether the slope of the terminal arm is positive or negative, and I make that determination.